From a standard deck of cards, a card is drawn. Give the sample space of equally likely outcomes. So in this instance, we're talking about a standard deck of cards, which has, well, let me pull out the Dyson card chart. So here's the Dyson card chart. This is a, you can see we have some examples for rolling pairs of dice down here. That's useful for other questions, but we're more interested in the full deck of cards. This is a standard 52 card deck. This is really the only deck that we're going to be using in this class. And if you're interested in seeing this PDF, it's called the Dyson card chart, and you can find it on MyLabs Plus. It's just one of the links on there. So in any case, talking about the makeup of a deck, you can see there's 5 different suits. These are generally called suits, or 5. There's 4 suits. The clubs, spades, hearts, and diamonds are the different suits. You can refer to the black cards or the red cards. Both clubs and spades are considered to be black cards, and hearts and diamonds are considered to be red, obviously because they're black and red, respectively. You can have 13 different ranks of cards. Ace, 2, 3, 4, all the way up through Jack, Queen, and King. These ones right here, the Jacks, Queens, and Kings, these are considered to be face cards because, well, they have faces on them. Jacks, Queens, and Kings, so you can count up the total number of faces. Well, there's 12. 3 by 4 is 12. 12 face cards. There's no question Ace is not a face card. And it doesn't matter. Some people have the question, are aces high or aces low? That doesn't really matter. That's not going to be the type of question we're concerned with in this class. So the sample space would be, well, each possible outcome would be representing each individual card. So if I was to actually list this out, I don't know, let's call the ace of clubs, the 2 of clubs, the 3 of clubs, and so on. Then I'd get all the way up through the king of clubs, and then I'd go on to the ace of spades and the 2 of spades, and so on. I'd have to have 52 different possible outcomes if I was talking about actually writing up the entire sample space. So the S here, our sample space, is the entire deck of cards. Each, the possibilities of drawing one card. So if I was to answer the question, what is the probability of drawing a face card? Well, the face cards, we saw that there was 12 of them. It's going to be the Jack, Queen, and King of each suit. So the Jack of clubs, the Jack of spades, the Jack of hearts, the Jack of diamonds, the King of clubs, the King of spades, whatever. There's 12 of them. 12 total. So that means the probability of drawing a face card, if we're just drawing a single card out of the deck, well, this is going to be N of E out of N of S. There are 12 face cards, so N of E, the event that we draw a face card, is the size of that particular outcome is 12. N of S is going to be 52 because there's 52 different cards. So we'd end up with 12 out of 52. If you wanted to, you could reduce this down to 3 out of 13. Now, interestingly, if you look at the 3 out of 13, each individual suit, there's 13 ranks. There's 13 here, Jack, Queen, King. There's 13 total. Notice that we end up reducing this down to just the 3 out of the 13. There are some patterns that happen like that, although I don't recommend relying on those patterns. I recommend just figuring out what is your event and figuring out the number of outcomes in your event. What is your sample space? What are the number of outcomes in your sample space? And then just do that ratio, and that'll give you your probability for these starting probability problems. These will get more complicated. Don't worry about that.